Okay, so hello, welcome to our next Brno Java user group meetup. Today we are going to have a very long deep dive into Java 25, which was released yesterday. So I am not going to introduce our speakers because we have 3 of them today.
Of these preview features landed surprisingly in the next LTS, that means 25. In the time of writing this, there was only one JEP known for JDK26, and that is the removal of the applet API, which is a bit showing what Java is doing. It's removing its legacy stuff, it's trying to be more secure, faster. Long time ago, somebody said that you write application now in 1995, and in 2025 it will run faster. It seems it's really happening. And by the way, on the applet API in Java Web Start, actually the Red Hat OpenJDK team was started, and quite a lot of people made a career from that. Deepak wrote the applet for OpenJDK, and he is now the CEO for Java in IBM. Yep. Quickly going around this evolution of the JEPs. So we can see that generational Shenandoah in 2 phases. Another generational ZGC, generational Shenandoah, again 2 versions of incubation. Now in 24, Windows 32-bit was removed. In 24, in 24, preview, removal of the 32-bit for Linux. 25 removed, removal of the security manager. So you see the legacy things are going away. New features, synchronized without pinning. Compact object headers, again, this is going to make the JDK faster. In the build space, a lot of things about the ahead of time compilation. It's happening for a long time now, it's really getting interesting. And we can also, the linking of the runtime images made a change from 21 up to 25. And JFR is getting the new features. One unfinished JFR, Java Flight Recorder CPU profiling is still experimental. Jiří will show you the demo later. Cryptographic features. Again, the only thing is, surprisingly, they all were made in one attempt, except the K-derivation API. But again, it means that the Java is keeping on the top of the things and have the latest algorithms. Small language features, stream gatherers, unnamed variables, Markdown documentation. Boom, everything developed surprisingly quickly. Yeah, deprecation of the direct memory access, new foreign API, and removal of the JNI in future. So again, removal of legacy stuff and improving what can be improved. And stable values were not finished in the time of JDK25. However, some of the things were really cooked for a pretty long time. Statements before supper. Yeah? It took 4 JDK versions to develop. And it's quite surprisingly simple change which didn't need JVM changes. Module import instead of packages import, 3 JDKs to develop. Again, this is surprisingly small change. And implicitly declared more easy way to write a hello world. Again, took 3 versions of JDK to develop. However, this needed small JVM changes. Class file API took 3 versions to develop, but that have sense because the bytecode manipulation have to go with the same speed as the JDK development. Up to now, the bytecode manipulation libraries have quite a lot of work to actually keep peace. And the scoped values was pretty big change, so it took 4 JDKs to develop. And what was not finished? Vector API, so the single instruction multiple datas. Since JDK22, still not yet finished. Structured concurrency, okay, 4 JDKs in development and didn't finish at the end for now. And the primitive types in patterns and instance of in switch, still also preview feature. Surprisingly, one would say that these are easy changes, but no, these are big players. And this is the only JEP which was dropped at the end. The string templates were introduced in 22 and dropped in 23. The reasoning for that was that it was quite a complicated feature to do actually nothing. Java, moreover, can do that as it is right now, so no, the huge patch was at the end rejected. Now, I will have demo for each JEP, yeah, which I have just spoken about. So I have 22 demos, then Karm have demos for each of these JEP, and then Jiří. It's quite a lot, so I will be skipping some of them because there is not enough time. Feel free to ask questions in the meantime. There will be a lot of source code, so if you do not understand, feel free to ask. Okay. First, changes without demos. Yeah, late variant expansions for G1. This was one of the biggest changes in the scope of the source code because G1 had hooks in the C2, and the goal of this JEP was to remove it from the C2. Anybody guessing why? The reason is simple. There is a lot of people understanding G1, but nobody understands C2. So remove it from C2 makes the code really much more readable. The authors of the JEP have promised from 10 to 20% speed of applications. I was unable to measure that. So no demo here, I really didn't make it. But the cleanup of the code base was huge, and we can actually expect quite a lot of work happening in G1 still. Now, non-generational mode removed in JDK24. To be honest, I don't like ZGC. I have to ask if anybody of you is using ZGC. No. Well, my work is to compare various garbage collectors in various cases, and ZGC just misbehaved for me because of the chord pointers. Its memory requirements are just huge, so I had to gave up on that. So maybe this is measurable, but I didn't try. Generational Shenandoah, again, going hand to hand with the ZGC. Actually, what the generational keyword means here, that means that the garbage collector is dealing with each generation of the objects by different algorithms. I guess everybody here knows that there is a lot of generation of Java object, short living, long living, something in the middle. So the generational keyword means that each of the generation is treated separately. I actually have nice test suites which are testing that each generation is processed correctly. Again, I was unable to measure impact. When I was speaking with the authors of the Shenandoah, they said that I need really complex application. Bad luck. I was unable to prove it's really faster. And now a lot of demos ahead. So region pinning for G1. The promise here is to, not the promise, the fix here is when you are calling old JNI, there is a trap. There is something what is called critical section, and that is when in JNI you usually have a copy of the object, and if you need a direct access to an object, well, usually the array, only the arrays, if you need direct access to the array, you can enter the critical section, and then the garbage collector stops to work. It waits until you leave the critical section, so the recommendation is to stay as short as possible time in the critical section. Okay, here we go, that's this. What we have here, yep. So we have some native method here. That's the heartbeat. You see that I am entering the critical section to access the array, exactly the array as JVMC, it's not the copy. Well, then I am delaying a lot, so doing exactly what I should not be doing, and then I am leaving the critical section. Then there is the hello world, so it's loading our native JNI call, and then there is running a thread. First, it started the thread, which is actually just allocating, what is that, 1 megabyte. Yeah? And we will see, and there is a second thread, which is launching my native method. And you would guess that this is running, and I keep allocating here, but we will see it's not true in JDK21. Now, a little bit of the copy pasting. Actually, all the demos will be like that. So if you don't like that, bad. So let's build the native code. Sorry for the copy pasting, but I usually make a lot of typos. Yep. So we build the native library. Let's build my hello world. In this case, we need that. And now I will launch it with the JDK25. So it's running with only 10 megabytes of maximum heap and will be sleeping for 100 seconds in the critical section. Now the output will be started. This is the native method, and now this is the allocation which JVM did. So there was visible that first we entered the native code and it's there. No allocations are happening. The garbage collector in this case is not throwing out of memory because it's not happening, but it's not freeing the old memory, so we cannot allocate. It's blocking the allocation because there is not enough memory, but no reason to throw out of memory. And this we will run with the JDK25. You see, allocations are blinking. Have you seen that? Yep. So yeah, it's still running. Sorry. Yeah, you see that. So the allocations really improved. Actually, this was a really huge change. It was one of the most complex from the how hard it was to do that. But to spoilers alert, if you run it with the Shenandoah, it will work in JDK21 correctly. If you run it with JetGC, it will not work in 21 nor in 25. Another reason to stream light now. So JGC is awesome. Yep. So that was the JEP region pinning for G1. Restriction of the JNI. I'm going to skip this demo. Generally, what's happening is that Java is trying. Actually, let's show the code at least. Then restrict JNI. Then boom. Yeah. When JVM is entering the calling Java native call, let's show that. What's happening? Then again building the native code. Then good. And if we will run it with JDK21, we have sorry. What's happening there? Sorry. Yeah. Point is that in JDK21 you are able to run your native code without issues. Yeah? In JDK25 it will print you a lot of warnings, but it will work fine for now. But the long-term goal is to restrict JNI, so you cannot use that unless you explicitly say that your module can access native memory. Otherwise, in future it will fail. There are of course the new APIs. That is the foreign function calls, which is the new approach. Is everybody understanding actually this code? Does not look good. So there is the main method again, the C method. This is the old JNI. You needed this boilerplate to be able to call any native code, but the foreign function call is allowing you to reuse directly the native methods as they were written correctly in the C. These foreign functions calls were throwing warnings since its implementation. So what this JEP did was just it aligned everything to the same thing. Now you have warnings everywhere, and be prepared in the future your JNI access both with the foreign functions call and with the JNI will be limited, and you will not be able to call that unless you allow that module to do that. Permanently disable security manager, another strengthening of the JDK security, because it was always buggy and always unsecure. Java should be secured by different ways, despite I'm not sure which. This is just checking the code, because security manager is deprecated in JDK 17. Already in JDK 17 you will get a lot of warnings when you will be compiling it and running it. You can still be running it. Even in JDK 25, you can still run the security manager without the issues. You can have the code, you can have the security manager, you can instantiate it, but it will protect nothing. If you try to set it as the system security manager, it will die and it's not possible to be enabled. So this is for yeah. So this is the class here. This is my method, and there is some internal class which is extending security manager. This code will compile in 17, in 25, in 21. It will print the same warning that you are using security managers and you should not. The JDK25, however, if you will try to install it, it will fail. It will fail even in the JDK21 in the same way. So the only difference between 25 and 24 in this case is that you cannot allow that. You know, this nice property which was allowing you to work with the security manager even if it was deprecated was enabling on the command line on the startup, so it will stop to work, you will get the permanent error and no starting. And if you see the lines in the JDK, it would do nothing. There are no more checks on the security manager. By the way, this is check out from the JDK mine trunk. In the JDK 17 I was checking up GA, but in the other JDKs I was not. Anybody knows why? Why I am not check outing the GA? That's because now the JDK forks before the GA, so you can check out the GA only in the fork. Sorry, technical detail. Yeah, I already said that the main difference is that you cannot allow the security manager anyway.
That's something literally nobody knows, or like 10 people cares about.
Yeah, two different things. Nobody knows. Everybody was enlightened, but nobody cares about true. Sorry.
Well, security manager, come on. Application servers?
No,
I know.
I mean the
because of the application.
the
No.
tidbit
The
about
checkout.
the tidbit about the when is JDK forked and
Yeah.
security
No.
manager is huge. That's nice.
Okay, back to the interesting demos which landed recently. So the JDK in the JDK 24 landed this JEP, Synchronize Virtual Threads without pinning. That sentence cannot be shortened. Yeah, and there was a lot of work behind because the internal implementation of the synchronized keyword was changed. Virtual threads are with us quite a long time, but they have one small bug. I guess you know that you have 10 virtual threads and then you have a carrier thread, and the virtual threads are swapping in the carrier thread, which is a normal native thread. And if the thread, the carrier thread is running one virtual thread, the virtual thread is bored, so it picked up, it's dropped, and it's picked up another virtual thread. However, up to JDK 24 included, when the virtual thread was not bored but blocked, or really blocked, then even the carrier thread was blocked. And that was moreover that usage. It made a lot of people unhappy. So finally, in JDK 24, it's fixed. So let's show that. Where are we? Yep. So what we have here? So this is the client. It will be connecting to the server. It's quite dummy thing. This is important. I am executing the virtual threads in the pool. I am executing 10,000 virtual threads, which will be carried by some 20 native threads. Yeah, it's not up to me. It's JDK. You can probably change the logic, but you do not need to do so. So this 10,000 threads will make a request to the server, my localhost server, simply reading from the input stream and dropping the data, let's say. Yeah, quite ordinary application, which will not behave as it should. Now the server, simple server socket. Everybody, I guess, knows that. However, the server replies are simply delayed, so we will be blocking the client for some pretty long time. We will need the server, so let's start the server. Now the server is waiting for us, and we run JDK 21. mine. So it will be creating 10,000 virtual threads running on some unknown number of the carrier threads, but each of the virtual threads will be blocked, and it will be blocking also the carrier. So you see, that's it immediately. So this is the number of the threads. I guess 2 threads belong to the JVM. So we had 20 carrier threads, and it got blocked, despite we should have 10,000 threads here created. So this is the pitfall which a lot of developers was facing. And now simple change with JDK25, it behaves as correctly. We had 10,000 threads which are waiting for the reply. Now that's correct. So this was heavily improved. A lot of application server developers should be now pretty happy. Actually, the clients, sorry. Any questions to that?
This is just solving synchronized.
Yes, yeah, that's important point. Yeah, that's correct. This was happening only if the client request was in the synchronized block. If it was not, then it was not happening. That's why it was not that critical, but still it made a lot of people unhappy.
Yeah, but that also happens in one other case when you are doing native calls.
Right.
If you have a native call in your stack.
With virtual threads.
Yes. It will still be.
Didn't know that. Okay, thank you. Yeah, where is our server? Oh, here it is.
Aren't sockets also native calls?
Very likely, yes. At the end there will be a native code. So I guess this blocking have to be based on the native code, actually, on the real blocking. You know, if you put there sleep instead of the blocking operation, it will just do correctly what we were expecting. It will create 10,000 sleeping threads.
And another issue is that like carrier threads will scale dynamically based on the number of requests for virtual threads. So
Depends.
you will more likely run out of memory than like.
That's also true. If you are using a scaling pool, then yes, it will just be creating more and more native threads, and yes, you are doomed. Going on. Compact object headers. This is probably my most favorite feature, which landed in JDK25, because it had fully evolved in the Brno OpenJDK and was fully implemented in Red Hat's OpenJDK team. Since the origin of the Red Hat OpenJDK team, we were comparing first IST6 against the Oracle 6. It's streamed, right? Then we were comparing OpenJDK against other JDKs, and now against the OpenJ9. And several years ago, we noticed that after under some loads, OpenJ9 behaves better, even if it should not. So that takes several years, I think, to find out that the only difference which is causing all the performance drops is the size of the object header. Because after our nice object, there is several bytes. Actually, it was 96 or maybe up to 128 bits, which is identifying the object for JVM. Yeah? So JVM can operate with that. Now, with the project Lilliput, there is only 64 bits constantly. And to be honest, yes, this feature was developed with some looking into the OpenJ9 source code. It was inspired by the OpenJ9, that's a better sentence. Yeah, the feature is there, it's not a preview feature, but you still need to enable it by default. Now, this will be nice demo, I hope. This is JEP 509, 19. Compact headers, yeah. So what we have here. The mine method is quite simple. I will make a small change here. There is my object, dummy object, which is carrying just one integer. And then there is a method where I am simply creating this object forever. Yeah? Running, creating this object and waiting for out-of-memory error. That's all. The code here, which is complicated, is because I am catching the out-of-memory error, which is not exactly deterministic. We may not see the result at the end because it died. Yeah? Okay, now I will again cheat a bit. So, okay, the maximum memory is important here. Again, the maximum memory of 100 megabytes mean that we will actually be waiting short time enough to see what happened. JDK21, I will be creating the one integer object until it dies. We have created 4 million object. Yeah? Now, running with the JDK25, again, same memory limit, enabled compact headers. Do you think there will be more objects? Guessing so, okay. And there is exactly the same number of the objects. Anybody guessing why?
The switch.
Sorry?
You need to switch.
No, switch is there. Okay, can it be that the object header is out of the heap and it's in hotspot native memory? No. No, it's not that. Object headers are in the heap. Actually, as I'm saying, this was a tricky question because this is really an extreme corner case. The reason for it why it created the same number of the object is that hotspot is aligning the objects in the heap. So in this case, the one integer is so small that it doesn't matter if the header is that big or that big, because the alignment will kill it later anyway. So this is the reason. If there would be more than one integer or less than one integer, actually anything else, then we will see it properly and it will work. So sorry, I couldn't resist to cheat here. But at least you know the object header is not on the is on the heap. So again, running with the JDK21 with the 2 integers, and we have created some 3.5 million of the objects. Now running with the JDK25 and our compressed headers, and we are again on the 4 million. So we see compressed headers work and had some impact, 500,000 objects more. Yeah, go on.
Why is it not enabled by default?
Good question, and I don't know. I was asking, and simply, well, the compressed pointers were also disabled for a long time by default, so I guess this is some safety hook. If somebody is doing something evil with JDK, they will not hit it immediately, my guess. Actually, I was the people who developed it, I was speaking with them. It was a more of a choice. Let's do not enable it by default, not necessary. Everybody can enable it if they want and need. Going on. Unnamed variables and patterns. This is JDK22 feature, but I will show you anyway, because there are some nice... Anybody using that? No. Interesting. Usually this is when you are iterating some array or list, then you have integer a, double colon, and then the array, and in many cases you do not need that variable there. So you wrote that code, and several years later you return, and you come and see why there is that variable, what is that doing? So this is exactly what this is supposed to solve. Now you do not need to name that variable, and it will be obvious on first glance that it's useless. So, unnamed variables. Again, so this is how your code usually looks. You have some integer of name a, which is doing nothing because we are just counting something and that a is useless. Similar here, we even need to use our creativity and create 2 names, which are completely useless. So now you can do this. Yeah? You do not need a variable at all. Yep. This is for the theory. Now a little bit for the prax. I will compile the yeah. Sorry. Let's compile it both with the JDK25. So we will compile unnamed vars and we will compile the named vars. Good. And now we will look what we had created. These are our 2 classes, how they ended. Yeah. Do you think that the code with the unnamed variables would be different? Okay, who think it will be different? Nobody. Ah, okay, 1 poor soul, good. Anybody more?
No, nobody can read that.
And I cannot make it larger because this is my tool actually, and I think I didn't implement it any font sizes. Sorry for that. If anybody is not seeing that, please sit there because there will be a lot of examples in this tool. Never mind. This is the named variables, yep. And let's compare it against the unnamed variables. So let's compare it, and you said there is absolutely no difference. Yeah, only one was compiled from unnamed, second from named. So this is just the syntactic sugar. And if you will look to the decompiled code, then you simply see that it's anyway loading all the variables anyway. Now, interesting thing in this is that if you will attach a debugger to that any good debugger would be able to show you the value in that underscore anyway. Yeah? It will just not say that this variable have this value. It will say that this slot in the stack have this value. Yeah? So access with debugger is still able. It's not optimized. It's still normal variable.
You have Fedora, right?
Yes.
Try DNF install Magnus.
Actually, oh, it's doing something. No, it's not doing anything. Magnus.
Magnus. Yes, I believe that should help.
Will it break the system?
For sure. It's DNF.
Magnus, like that?
Yes.
I'm offline. Bad luck. Oh. Oh.
It will help, especially if you have more demos in.
Okay, I will see if there will be more interesting memos than demos we will see. So that was the compile. But if it will continue like that, I will install that. Launch multi-source code programs from the without compilation. This was introduced in JDK22. It's quite nice feature. Actually, you may notice that I am using it since the beginning.
Now you need to make it bigger.
Oh, how come? Yeah. Good? Yeah, sorry. However, there are several corner cases in the source code starting, which I would like to show you, even if it's a JDK22 where it landed in. Yeah, what we have here, we have the main Java, and then we have some package with some dependency. And if you would launch that with the JDK21, that it will probably fail. Boom. You see, I didn't see the source code, sorry. The source code is this, main Java. It's printing hello world, and that it's calling that hello world in the package, which is just printing out hello world from dependence. Yeah, here it is. It's not there. Yup. So you see this launched the source code in JDK21, and it couldn't found the dependency. Actually, is this a runtime error? Because I was running that. It's not. Just a small heads up on this topic. The running of the Java source file directly is very nicely implemented in the JDK, because it's looked to the class path. If the class there is there, if there is a class path, it will be used. Sorry, if there is a class, it will be used. If there is not, if there is .java file, it will be compiled, and then in JVM there is just class. So except that small memory footprint and processor footprint of the compilation, it is the same as running the classes. So if you will be running this with the JDK25, oops, boom, we have hello and hello from dependent. So finally we can interpret in the packages. Glorious. There is a small trick actually. This was simple because this is the Java, main Java, so there is nothing to decide. However, if we build that, main Java and directory. Now it's getting to be tricky. There is one class of that main, and there are again two classes of the dependency, two classes of the main. So let's change that a bit. Let's change that a bit. This is somewhere printing hello, so it will be printing bye. I hope I am in the correct thing. In the worst, it will crash, and now we will blast the.com. Boom. Bye. Yep. So I have changed the classes so they are different from the Java source codes. Now try your guess. When running the Java file, it looks like this. So, do you think that, I guess we will launch this one, that's pretty sure. But which of these two do you think we will get? Who is thinking that we will get the class? Who is that's half. Let's say half to half. Okay, they are one class, one Java file is 50 to 50. Okay, so let's show that. Boom, and it picked the source. Yeah. However, if we run it like classes, it printed the binary mine and the class dependence. Yeah? This is moreover security reasoning, because in the old application which will be running by the JDK25, you could have some resources .java, and this is avoiding them being used and your code to not be compromised. The only exception is when we lost the source code. Yep, dependency Java is lost. Then this is not interpreted, with this source code launcher will use the dependence. Yeah, this is the only exception. Yeah, so that was that. Be aware with that.
Will it work with Java?
Sorry?
Will it work if you package it to Java?
It should be exactly the same in the jar, because in the jar there is the danger of the Java as resource. It should behave. I think I tried that and it behaved like that. If not, please report the bug. Compact sources, files, and instances of mine methods. This is for JDK, so 2 years of development, how to write hello world faster. It may be funny, but the reason is that somebody thinks that public class, hello world, public static void, mine, arc is too long for students to learn. So the reasoning was to remove the boilerplate, and students should be now more happy. Compact sources, what we have here. Now, sorry. This is hello world in the new way. All these 4 are the correct writings how to write hello world in Java right now. They can be static, as there were. They do not need to be static. Then take args, as they were using to take arguments, and they do not need to take arguments. Yeah? So if you are learning on the school, your task is much easier now. Okay, there is go. What?
That static IO class for print and read line isn't final.
Sorry, what?
Like there should be like IO.print line or IO.print and IO.read line, so even system out is like.
Is it?
Simplified.
Maybe.
I'll try.
You are saying it should be like that?
Capital IO dot. Yes.
Okay.
I have to compile it.
Yeah.
Quite fun.
Okay, thank you. Didn't know that. Yui. Where am I? Yeah. Okay. Let's compile that. You see, okay, thank you, compilation passed. And we see that this class free hello world without the public static boilerplate is there. Now, if we look there again, which of these methods will get precedent? Which now we will be launching the class which have 2 mine methods. Which one will be picked? Anybody guessing this static without the arguments, or this instance method with argument? Who is in favor of this one? Quite a lot. Who is in favor of this one? Actually, the rest is in favor of what? Never mind, it was more over 50 to 50. Slightly more people vote for this one. And let's try that. And it was the instance with the arguments. Yeah, so the arguments are taking the precedent. If I would use these 2, then static void with the arguments would have precedent again, and you cannot have 2 and 4 and 3 and 1 together. You cannot have that. So that's quite obvious. Arguments have precedent. However, interesting thing to show. We will look to the class again. Was wrong. Was wrong. Oh, Java file record, sorry. File system here. So again, I'm going to that compiled thing. This is the compiled class.
And I need to install the thing that makes everything larger.
Okay, let's try that.
It's your mistake that you're not implementing the like zoom in your tools.
Yeah, sorry. Impact hoop. I feel good. I know that Alice is now laughing how many typos I will do. Let's see that. Okay, no typo, no typo. Are you sure with that?
I thought so. Maybe it's in like RPM Fusion or something like this.
Disabled. Ah.
Yeah, it's called Magnus for sure.
Sometimes there is some weird thing. It's not.
Give me a second.
Okay, so really nobody can read it.
I can read it.
Thank you. Anybody else?
Find the first line.
Second row is also good.
Yeah, it's a good memory.
Okay, let's continue before Martin finds the Magnus keyword. Now, this is the bytecode of that thing. I will just lower that slightly.
Snap install.
Okay, bad luck. Not provided. And now let's check the source code. This is how the compiler see that. So obviously the boilerplate was added. That's all. There is no magic in that. The boilerplate was simply added by the compiler, but there is some difference. Anybody is seeing what that actually JDK? Now I have changed the bytecode version, so JDK25 should be able to launch that. It's not, but we have the proper classes, proper MIME methods here, or do we not? We do not have. They are not public, that's all. Yeah, that's the only cheat. So yes, in this very simple job where the Java C is generating some boilerplate, actually a JVM needed a change. So the public is no longer necessary, and if we will add it, it will start to work suddenly. I have changed it. Okay. Oh, it will not, because this is incorrect completely. Oh. Ooh, what am I writing? Oh. Now, cannot resolve. I'm not going to bother with that. Anyway, JDK would be not able to do that because none of this is actually valid mine class. So within this simple job, really, touch to the JVM hotspot was needed.
Is it only for the main method?
Yes, it's only the main method. The 4 methods as we have seen them, they are the all, nothing more.
Because if you want to add another method which needs to be static, you need to write this word, yeah? You need to write the static keyword.
Yes, of course. This is still only my method. And the difference in this, what you are now saying, actually.
And beyond the joke about the students, is there any other motivation?
No.
Like multiple entry points to some libraries?
It really is not.
Frameworks.
The reasoning there is to, when you are starting the Java course, then in the first slide you are showing the student how to write a hello world is public final class mine with constructor blah 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 public static void. From that, static is unreasonable, arguments is array, it's unreasonable, and so on. You know.
Okay.
So really, this is literally for the educational purposes of the junior programmers. That's insult for students. And this really, no changes will be happening to your code. Nothing will be changed. The JVM had changed, so it now can read these methods as the entry points. That's all. So that's actually correct. If in your old code is there some MIME method like that, you can now launch it by this class. That's actually true.
And it will always prefer main with arguments, you said. So if you change the order, so the arguments are the second thread. Just keep the one without the...
Yes, the argument is always preferred. So yeah, this actually, some of applications are doing something like that. Yeah. So always the one with the argument is first, and if there are 2 of the arguments or 2 without, the static is first. So it should be moreover safe. You can find the glitches there, but you should not. They should not harm.
And can you call one method from another one?
Yes.
One main from another main?
Yeah. Yes, you can, without the issues. Yeah. So that was this. Small feature, a lot of evolution, and reasonable. Markdown documentation in the comments. Everybody here, enterprise development, is anybody using the Markdown in the Java doc? Is there in JDK23 and it's awesome? It's not, okay. Now the Markdown in the Java docs actually brings some unexpected issues, and I will show you them. Markdown. In this case, there is actually no. Like this, and we want. There is some my method because we will, which have nothing, literally just a lot of Java doc. Yeah? So what is there? There is a Java doc in the old Java doc, and there is a Java doc completely in Markdown. These two should be pretty obvious. But then there are two little bit weird cases, and that is when I am wrapping the Markdown one in the old legacy Java doc, or if I am wrapping the legacy Java doc in the Markdown. Surprisingly, this is from development. Some people did that. Yeah. Maybe, well, it's obvious. I have enterprise project and I have JDK24 and I would like to write this nice Markdown. So I added the new Java doc in the Markdown and they hoped for a good results. They were heavily disappointed. So I have pre-generated that and we have both of them. So here we have the Java doc, and then we there have actually this is P1, this is P2, this is some P1, P2, P3, P4, and P5. Yeah, this one what we see there is generated by JDK21, and the second one, actually this is correct. Yeah, this is generated by the JDK21. This is generated by JDK25. Surprisingly, the results from JDK25 are worse. So be really careful when mixing the Java docs. In the JDK21, okay, P1 is there as we expected, is the old classical Java doc. Good. P2 is there as we would expect it because it's the classical Java doc and it do not understand the slashes. It do not interpret them. P3 is not there at all. That's also correct because P3 was wrapped by some weird 3 slashes, and this is then not recognized as the Java doc. And the P4 is there too, and it's actually surprisingly quite good. So this Java doc was recognized, only the part of the Markdown was not. And then there is a P5, which is there too, as we would expect. Yeah. P5. Oh, it's not. Oh, sorry, it's not there as you would expect because it's completely Markdown. Now, JDK25, what it had produced. P1 is there because it's all Java doc. We still can speak that. P2 is there. Unluckily, it still do not recognize the Markdown. Even if it's there, it's understandable. No, it's started like that, so it's old Java doc done. P3. The mixture, the second mixture, is not there at all. That's starting to be tricky. So our nice markup Java doc ignored the P3 because slightly later there was P4, which probably took preference. However, that's not there too. So be aware, this will make your Java doc completely disappear. Yeah? And P5 is there as you would expect, so and is nicely formatted, so the feature worked. But be careful with the mixture.
This is enabled by default?
Yes, the Java doc is just, as you have seen that's the default.
It will be a nice surprise for people when they...
It already was a nice surprise for a lot of people. So, going on. Module import declaration, that's, let's say, another very simple thing which took 4 JDKs to evolve. What was that? 511. Module import. What we have there, 2 classes. And first one, in the old way, we would write it like that. Import Java IO package, import Java util package, and then use the package. In the new world, you can import simply the module Java base, and it will import everything from that module for you. Nice simplification. And 1, 2, 3. it's honoring the export import by default, even if you are not using module system. So it will not read the non-exported packages. However, there are again small cheats. In this example, we are using module java.desktop, which actually back to this. I will show you because in this simple topic first. Let's compile it by JDK25, and it will obviously tell the error that it cannot run because it is no module imports are known. If we will run that, compile with the JDK25, it works fine as we would expect. However, funny thing. Oh, again, when we look to the output of the compilation, then again to the byte assembly. Yep. Again, I will lower the bytecode version, or maybe starting from the beginning. Yes. Sorry, a little bit jumping. Now we have compiled it by the JDK25. Will it run with JDK21? Anybody, any guess? Of course not, because the bytecode version is broken. Oh, I wrote it wrongly. Sorry, Java C. The bytecode is wrong. That's all the magic. Everybody knows that. And yes, we compiled it by the newer JDK. There are definitely newer features. So let's again look to the bytecode. And let's change the bytecode version. That's the only protector here. Yep, we have changed the bytecode version. And we are using the import module. We have changed that. Good. And now, do you think it will run in JDK21? Who think it will be running? Why? Why it will be running? It do not speak module import. It didn't speak module import. Why do you think it will be running? It will be running. Indeed, it's running. Yeah. The reasoning is that in a bytecode everything is fully qualified. That's all. It do not have any. It does not care about the import. Everything is fully qualified in bytecode, so we are done here. Now the second issue here. This is slightly tricky, but JDK was prepared for that because the element. Let's see. You see the example. Dummy. Let's compile that. Java C 25. Let's compile number 2. There is an error, compilation error, because the class element is in 2 packages. Yeah? The resolution there would be simply fully qualified element. That is slightly disadvantage against the packages imports, but at the end I like this feature. And to have one fully qualified element, especially if it is completely different. So if I will change the if we will change that, so the element is now fully qualified, then the Java C should be okay. Compiled, done. Yeah.
Could
So-
we just add the import for that one class?
Sorry?
Then you just explicitly add one import for the one class.
Let's try that. I don't know.
Disambiguate, maybe.
Let's try that. Interesting. Oh yeah, we should. Like that.
No,
What?
I mean the element, probably.
You want the element, sure. Yep, tak. Happy? Okay, should work. Java C worked. So yes, the narrowing is using actually. Let's say what will happen now, just for curiosity. Too good, thank you. So yeah, fully qualifying the element will solve it, and you had seen that the Java C is nice about you, and it will tell you which choices you have. Finally, flexible constructor bodies. I guess everybody there was using some inheritance in Java, so my object 1 as extending object 2. Everybody knew that if we are calling some more logic in the constructor, first we need to call the supper, and then we are doing our logic. A lot of people suffered with that, a lot of people made a lot of work to somehow avoid that. Now it's no longer necessary. And that is again nice thing to show. Okay. So this is some class master, which is printing something out in a constructor. And then there is a second class, which is extending the original master, but is doing this awesome thing. Awesome. It looks terribly for everybody used for Java to have a supper on the first line. Now you really do not need to do that. I am in the main, I am calling the kind master, instantiating the kind master, and we should see this ordering. So first, are you master? I am your master, and I am kind master. It should work like that. Now, let's compile JDK25. Crash, because we know that the supper have to be first call in the constructor of extending class. Now, if we compile that with the JDK25, it compiled correctly. Nice thing to fee inside again. So bad luck in the intro, obviously. Now, this is our kind master. Let's check the bytecode version only. Yeah, sorry, I was stupid again. If we would be running this, the JDK21, again the same issue. With the running the Java method, it's the compilation failure, and running the binary class on JDK25, wrong class version. Yeah, nothing surprising here.
I have a question. If people can read that from the first row.
Yeah. Yes.
I was asking. Okay, now let's change the bytecode version slightly, so we will be able to launch that by 21 maybe. Change that, good. Subclasses, change that, good. And another 59. Now, don't read the disassembled code, it will spoil a surprise. Now, do you think it will run with the JDK21? Any bets? Who will think it will run? So you do not trust JVM. Good, probably. Let's try that to run that with the JDK21. And it works! Why? Why we were suffering all the years with the supper on the first line? But yeah, it was actually visible in that source code, which I have shown there. In the first two rows, it was visible in the calls actually that the bytecode really do not care. It do not care at all. This is, you see, it is calling "Are you a master?" Then it is calling the init, and then it is calling the second print out. The bytecode didn't care at all what's the order of the supper. It was there just by decision. Yeah? There was no change in the hotspot to allow this change to actually work.
So there was like really a compiler checking if it's the first.
Exactly. Okay, that was that. A lot of people probably committed suicide in a long time because of that. Anyway.
But there are some limitations, yeah? You can't do everything before.
What I was trying, you can do more likely everything. What you would think it should not happening there. Probably there will be some nice things to do which will harm it, yes. But I was checking quite a lot and I didn't hit anything nasty. No? And no surprises was there. We were able to do more over anything.
You were able to access the parent of the class and so on and so on.
Yes, you were. So, actually, is that parent classes? There was some issues with that. Thank you for pointing it out. Anybody, should I try that? Okay, let's try that. Yep, this is some function. And how we would call that here, actually, let's make it public.
Or just a variable and assign a value.
Let's try that. And now we should be extending. We should be able to call hello. Yeah. Feel free to correct me. I have how many beers, so not sure with my Java code. Does it sound correct? Thank you. And let's compile that. Let's run that. Hello. Cannot reference hello before subtype constructor. I think that's self-explaining enough that you cannot do this. Good, thank you. Back to this. Linking runtime images without JMODs. It's there since 24. Again, I really like this job because it was done in the Red Hat OpenJDK team, but it was actually one-man show to implement that. Is anybody using JLink in the work as a delivery method of your applications? No, surprisingly, not much people likes that, but I guess more and more modules will come in play. It will be more and more interesting. Anyway, JLink is backpacking your application, and everything it needs from the module world plus JDK itself, but only the parts it needs from JDK. So if it's headless, the AWT library will be missing, and so on. To do that, you had two JDKs on your file system. First there was the JDK you were using, and then there were some files called, how they are called?
JMODs.
.jmod, yes, JMODs. And in them, there was a second copy of the JDK, complete second copy of the JDK, just to allow you to create JLink images, and the reasoning was that you actually needed a immutable correct version of the JDK to be linked in your image. The JLinks are still there and have their purpose if they are doing cross-compilation, because your image is native if you are including JDK in that. But some of the developers were complaining, actually one of them, was complaining loud enough to actually be allowed to do this job. And the reasoning was that you are usually not cross-compiling. So why to have a second copy of the JDK there? And you can JLink from your JDK without JMODs. It has limitations, you cannot cross-compile, and your JDK must be untouched. This is a little bit, a lot of time. Skipping this demo because it's a long one. Generally, if I would edit, for example, the man page for Java, then this JLinking will fail, because it will tell you your JDK is templated, done, bye. You are probably not editing the main page, but it is complaining also about the tzerts and other files like little config files in the JDK, so you cannot use them. Yeah? It's the same as with the JMODs files, only now you will see that. Yeah? So that's it. And really, I would like to highlight this is one-man show. One developer didn't like that, and he implemented it for the Java in 2 years' time.
Can I just have a question regarding the super?
Mm-hmm.
Because the error was that you need to make sure the super is called before you can call the base class method. So the compiler needs to perform some analysis. For example, you had like if-else statement, and you only called super in one of the branches, and the condition depended on something non-static. It's interesting, like if it could analyze like the super was really called.
What's that?
Sorry for
no,
getting back
that's
to
good.
that.
We are still there. Oh, it's actually still there. That's this. So, something nasty. Like that? Does it sound correct?
Maybe actually having the super inside, like that is the conditional thing.
That's exactly the nasty thing you should not be doing. Actually, I will first try that and then try the condition super. Because
maybe on something non-static, like reading some system property, because
I understand.
Constant, it's too easy.
So yeah, so this was found by the compiler.
But you must also.
This thing, even if this should be omitted because it's never used code. So even in this case, JavaC complained about that. So you see, and this, that's terrible.
No, I think actually like that whole statement should be before the hello call.
Understand? We will see. Maybe if we are not calling supper, then it's actually then like that.
No, I think that's the same. Like we already had this.
So go on.
So
remove hello.
Yeah, remove the hello. Yeah, leave it like this, and call the hello afterwards.
I think that already this will die.
need to call super.
It died already now. Yeah, doesn't matter on the hello.
Try to call it after the if.
Sorry?
Try to call it after the if.
Let's be done.
Sorry, what was the error?
Still the same. Not allowed here. The explicit constructor invocation is not allowed here. I think that's quite self-explainable. Self-explainable. Go on, torture me.
So you cannot have it protected in an if statement, basically. If you put an if true, that should work.
It should, but it will not. Well, we'll see. I think that the compiler actually is including this if statement, so that this will fail for sure. Yeah.
So it needs to be like top level constructor.
Aren't you looking for a job as a JDK Yeah. So yes, I was slightly unfair to the feature. Yes, obviously the Java C needed some improvements to be checking this. Thank you. I apologize to the Java C if anybody's looking.
Another thing, if you add to line 17 else and call super again.
Like this?
Yeah, this is fine.
What about the second sentence?
More errors. Okay, no more torturing. Yep. Linking runtime images. Yeah. I think I ended this. Yeah, this was everything for this topic. Yeah. So your JDK must be immutable. If you modified that for any good reasons, JLink from that will fail. Same as with the JLink, because in the JLink your changes will be ignored because they are read from the JMODs. Anyway, warning when using the direct memory access from sun.misc.Unsafe. Sun.misc.Unsafe has methods which allow you to allocate code out of the heap. That's quite useful for some really nasty things. Now you will get the warnings in JDK24. On the long term, these methods should be disabled. Foreign function and memory API. This is in JDK22, but I will show it again because when I was showing that in that warning demo, didn't seem like familiar. Sorry, with Jeb, but it was for. What we have there? Again, there is some mine method, but especially what we see. I will not be launching that to sake of study. So what we have there is the old one. Now, okay, mine method this is the old thing. We have native method, native hello from this native library. We are calling that. That is this terrible thing which you need to write or let generate so you can print hello world. However, classical C functions are written like that. Yeah, it's nice, readable. Now, with the new approach to access the native code, you can do this. It looks like pretty verbose thing, but it's actually quite readable and nice. So we create a linker. We load our native library, and then there is some long call that we will find a method add, which you can see this method add. So you write it just like that nicely. We will tell the foreign function API that it is returning double and have parameter double and second parameter double. Yeah? And then you call it like that because this is the method handle where you invoke two doubles and you are getting the double. Yep, nice, clear, recommended way. However, still you will get a warning to use that. The native code is going to be locked by default. You will need to enable that, and I do not have it. That enable native -- enable -- native equals this module which can access the native code. Yep, that was that.
Are you still going to do 11 or 10 another jabs before the
3.
boss?
I have 3 jabs before the break.
Okay, then we can do that before the break.
Thank you. Thank you, boss. Class file API. I guess anybody there using the bytecode manipulation libraries? 3. Ah, not good. So yes, these are bytecode manipulation libraries. and do not swap with this JSON. The JSON code is a disassembler of Java, which you see in that tool of mine. Now, these libraries had a hard time to follow the bytecode development. Despite the bytecode development is very, very slow, sometimes there is nice change, like the invoke, dynamic, and so on, which were hard to put into the bytecode manipulation. So finally, in 3 or 4 JDKs of development, JDK have embedded bytecode manipulation. The main reason for this is not to allow you some nasty things, but to allow agents to transform the bytecode more fluently in the JDK. I think that the second presentation is going to be cancelled.
I hope not.
There is a disassembled laptop. Never mind.
Don't let me disturb you.
Okay, now anybody using the Java agents? Java agent is a jar which is injected into the running VM, and then when JVM is loading classes, it is pushing them through the agent, which have input of byte array, which is a class, and output of the byte array, which is the new class. Yeah? So it's transforming the Java classes on the fly. Boom! I'm skipping this demo because it's a complicated one. Generally, what you would see that it's just changing the car. Stream gatherers. Is anybody there using a custom collectors for the streams? Custom collectors? No, not good. This is the interface collector. When you have the result type, accumulator type, and the stream type. Yeah? And when you are using the collector, then how to tell that? You have stream. You have some array or list. You change it to the stream, and then you are applying the transformation map, whatever. Yeah, I guess most of everybody familiar. Good. And however, all these operations are stateless. That means that they know the value of that element, but they don't know the future value or the past value. It's forbidden. You cannot do that. If you need to do that inside the stream, then you really need to do a lot of nasty programming. Was anybody doing that? It's possible, but it's terrible. And then you are streaming, and at the end you are collecting that. In the collector, you already have the access to the past and future elements, because the accumulator is usually the list, where you are storing elements, and when there is enough for you to process it, you use that content of that array or of that list. Not seeing much understanding. Let's show the code at least. But this example is not nicely readable. So this is custom collector. I have some list. I am streaming that, and I am collecting that to with my custom collector implementation. And now, if I would like to have a stream operation with the custom collector again, then I need to again change it to the stream and then collect it again. That was the pitfall of the stream API, that you cannot affect the stream inside where you would have the overview about the past and future. Because let's look to the custom collector implementation. The main method there is, I think, this consumer, where I have some, okay, you can have, for example, array here instead of that integer, and you can be accumulating in that. In my example, I am only, this is getting me the, actually, the integers in the original array, and if there is none, I will add it, and if there already is a saved value, I will add it to the output. So this is just adding 2 things in that list. So the output of this will be 1 plus 2 and 3 plus 4 in the array in the list of the 2 elements. If I call it again, it will be 3 plus 7, so 10. Yeah. But important thing is that I need to collect, stream, and collect again. With the custom gather, I can do exactly the same, only I can do it in the middle of the streaming. Yeah? So if you understand collectors, you can easily understand the gatherers. And moreover, this is all that I have to gain list. That gatherer is doing exactly the same as the collector was doing. Only I can gather and gather again. That's the difference. You can use stream and it returns stream on the output. it's pretty speeding up the operation, because if you need streams, you are already chasing the performance a bit. This will be adding another boost. Then scope, okay, wait, what? Yup, scope value, last one from my part. Scoped values are awesome. And there is starting to be lack of light. Oh, sorry. Scoped values. There is a bit of the Java code. Sorry for that. But it's the last one for this our session. So let's check them. Scoped values are solving the issue where you have a framework, the library you wrote, which is supposed to be used in multi-thread environment. Typical is the server implementation. Yeah? So my server have some context which I need sent down to the client code, which is then processed, and very likely it will be calling back to the framework where I would like to see that context again. But to do that, the application have to give it back to me, or I have to store that. Both approaches are tricky. This is the dream world, because my context is private static final, maybe can get any public static final, so application can use that. It's immutable, it's done. And there is some class client, which is just printing my context out. Simple, narrow, no tricks, and here I am starting it in the thread. Yeah, really simple, narrow. Unluckily, the idle words usually do not work, and we do not have that. So we have to pass for each thread slightly different context. So in this example second, I am creating new context. It's integer, but in your world it would be just some complicated class. And I am creating each client with that context. Sorry, this is just helping ID. I am starting the method of the client application with the context and running again in the API. It has several issues. You see, it's there. I need to call, I need to pass the context in, and then it can do more or anything with that. If the context is poorly written, it can be modified. Yeah? And if you refactor your code, then everybody has to refactor it, because everybody was using the context, or was not, this method was not using context, but now is. So you need to refactor, and everybody need to refactor with your library. This was painful, but working, otherwise not much issues. So you as a developer of the framework come with something like that. You will have a separate context for each thread you create. Yeah? So this is my internal map, and when I am starting the client, so I'm passing the context down to the library, I will put it for this thread, I will put it into the hash map. Client can then reuse that hash map get with the thread, current thread, so I can immediately access through my thread ID the context. Then somebody should also remove it from the hash map. Yeah? There is an obvious issue that first, this is a lot of code to write, not secure code. This map is mutable by default, so anybody there can set it again. Yeah? Of course, I can use some immutable map, but again, you are starting to code a lot. And if the thread executing my framework code will start another thread, then this will suddenly stop work, obviously, because the thread ID will be different. So again, we need to think more deeply. Obviously, the authors of JDK thought about that. So there is something like thread local. Question, who is using thread local? Thread local. Well, no, only 4 or 5 people. Well, thread local is doing moreover what we have seen there. There is something like map. Oh, sorry. There is really something like that. So the thread local is suffering the same issues as our custom map was doing. It's mutable. Yeah? We can reset it. If we call it in the subthread, it cannot be accessed, and we have to remove it. Otherwise, if we are, for example, reusing the threads, so if it's poorly written, then some of the reused threads may call the wrong context again. So the threads local are not preventing against that. And actually, In the thread local implementation, there is not a map, but there is a vector. Anybody knows why there is a vector and not a map? Anybody guessing? Because this is older than the collection framework. That's all. Or I think it was added in JDK 1.2, which is also the collection framework was added, but anyway, it was not there to implement the threads local. Yeah? So there is no map, it's terrible at the end. So, not running it for the time purposes. This is the example of the reuse. There is the fixed thread pool. If we are calling it by that and we are using it wrongly, then other threads may be really reusing the context. Again, it's mutable, and now finally these are the scoped values. It's initiated in the same way. So I create my context with the type of the integer in our application of some crazy object, and it's inverted the approach. So when I am now calling the thread, you can see that is still the thread, the same thread as I was using all the time. I am creating the context, and in that context I am running the work method. So this is how you use that, and it's immune against the both the post issues we've seen in the past. So it cannot be, it's immutable, so nobody can change it, and this would fail. I cannot fake it anymore. And if the threads are reused, then thanks to the concept, it will know. These are the examples of the failures. Mainly, this is the most important part. If you are calling the subthread, then you need to call it like this. Again, in that context, and your new subthread, because this is again thread, will inherit the context. And even this is valid, that you can change the context for your client work, but you cannot access it, and you cannot call it without it. Done. Done by me. Sorry for the delay. Break, and then Jiří will have a lot of crypto features for you. Thanks.
15 minutes? 15 minutes. Starting again, please.
So for my part, I will be talking about two areas. One of them will be the JFR improvements in JDK25, and the other part would be cryptography improvements. So for the JFR, the first area would be profiling. Like Java added CPU time profiling. First would be good to mention why we need profiling. It's a powerful way of optimizing programs, which I'm just reading aloud. So what we can do is to run a program and see like where or what methods are CPU heavy or intensive and optimize them later. And CPU time profiling is a powerful tool to do that. Until now we had ways to profile somehow programs, but they were all sample based. Basically it relied on wall clock sampling. What this means is that you had it used a real-time clock to sample. I think the default sampling frequency is 20 milliseconds, and it was quite well, the JET basically talks about this being not accurate enough, so that's why we have CPU profiling. The thing about my demo about the CPU profiling is that I was not able to replicate such good results that the JET promises. One of the things that I managed to replicate was that I had quite a lot of programs actually to showcase this. So all of the Java, I think I've made like 3 or 4 attempts, and I fiddled with the parameters of the programs a bit to just hit the right window so that wall clock profiling would ignore some functions. I can show you some of the code. I don't know. The thread demo would be a good way to show an example. Wait, what?
Swap file to remove.
Oh no.
Yeah. The best would be to quit and remove
I
the
don't
folder.
care. I like to live dangerously. So what this program basically does is, wow, I really hate this mouse. What? No, I'm not going to try them. So what this? Okay. Sorry, Karm. Yeah, so what this program basically does is that it has two threads, and they each of them executes one method. One of them is a busy thread that does busy work for 8,000 milliseconds and then sleeps for another 2 milliseconds, and the other one sleeps for 2 milliseconds and works for 2 milliseconds and sleeps for another 8. They're called lazy worker and hard worker. And with this, I've been able to replicate the best results where the busy loop was able to do like 95% of like this is the wall clock sampling in viewed in JMC. I know that people in the background don't really see the.
Install Magnus.
Thank you. Can't really see the letters, but the important part is that the wall clock sampling was able to see that the busy loop took about 95% of the CPU time, and the lazy loop only about 5%. Which is not really accurate, because we know that the busy loop ran for 8 milliseconds and slept for 2, and vice versa for the lazy loop. So we would expect a bit different result. I should have yeah, prompt text file here. Yeah. So yeah, I should also I should have also said how this is being triggered. It's this nice command where you tell it to start flight recording, and the important part is the CPU time sample, which is new, and you have to set it to enabled true, which adds some more events to the JFR file that you are going to generate here marked in the file name. Yeah, so you basically generate a file, and it will have both events, the wall clock sampling and the CPU sampling within it. So we have seen the wall clock sampling in the JMC view, and if we look onto the same file with JFR and tell it to just show us the CPU time hop methods, it will tell us that the busy loop took about 80% of the CPU time, whereas the lazy loop took 20%, which is a 15% difference for both of them. This was the best result I could have gotten, I was able to get with this demo. Okay. Let's go on.
What's the overhead of CPU profiling?
There should be none, which is a bold claim. Nearly none. That's an important word, which is a bold claim, but I think it could be. I've actually, my first attempt was to run Minecraft with it, and there was no visible performance dip within it, so yeah. Okay. The other JFR improvement is method timing and tracing. So if you want to trace methods, whether they have been called, when they have been called, how long did they run, this could prove useful to us, and it can be used on run apps as well. So if you have already running app, you can use GCMD, or on if it's running on server, you can use JMX to monitor that as well. Sadly, I have no demos for that, so sorry. But I have a demo for the general use in the generic code. Wow, I have to remember all of it, but I have to recall all of it because I can't remember anything. Yeah. So what you can do is that there's another nice prompt. Yeah, I have not updated those because I already updated my default Java to be JDK25 for the sake of these demos, so I don't have to run, still write this. However, the important part is again Java recording. You tell it to which part you are going to store it, and then there is this part about method tracing. You can trace either methods, annotations, or classes. You can even trace inner methods, classes, and annotations. So if you make an annotation within a class, you can track this as well. Yeah, and you just set a filter for it. So this is a base class, and this would be the method that you want to trace. There is a whole, if you search for the JEP, we could talk about the syntax of this for an hour or so, but I can't really, we don't really have time for that. Yeah, so first of all, I'll show the demo. And it's a really simple demo, just featuring basic methods like compute and helper. There is a demo marker, which is an annotation, and a class worker. So we can basically track any of these using this feature, and you can also track combination of them. You don't have to track just one thing, you can track everything. If you want to do that, you can use the configuration file, which are usually suffixed with JFC, and they are written in XML. I can show the configuration file before we run anything. So this is the basic configuration file. You can either track the tracing or you can track the timing. First of all, you will want to set the property to enabled to make it know that you want to enable the method tracing, so you don't have to switch between delete a lot unnecessarily. I don't know why I'm talking that much. Okay, and in the filter you have you don't have to specify which is class or which is method. It just knows by syntax, but you can know as well. The demo marker is definitely an annotation. This is clearly an inner class, and these two are methods. What you want to make sure not to do, and what I got stuck on yesterday, is that if you run this with bash commands or within bash, you need to escape the $sign, because the bash tends to expand it, and then you don't have to correct tracking. Okay, so let's see what this does actually. So we want to track, with this command, we want to track the do work method, and it generates for us the JEP 520 demo JFR file, which we can then, I should have a command over here, yeah. It generates the JFR file, and then we can inspect it with JFR. So in this case, we should get.
I think we didn't escape the $sign.
Really? Mm-hmm. Oh, so I've just copied the one command that's not working in the whole example. All right. Yeah, that's on me. Sorry, guys. Yeah. So it just tells you when it was started, how long did it take, how was it called, and from which thread it got called. And it will be something similar with timing, but for the time's sake, I want to show you the usage of the configuration file, because that would be a much better use case. So if I just show all of the methods that has been called, we can see that basically I tracked all the methods in the configuration file, but you can be more selective than me, of course. And you can see for each method when it started, how long did it take, and we can also change this to method timing, and it should give us, if you run the method for like multiple times, then it can also obviously tell you the average time it ran, the maximum time, minimum time, and so on. Yeah. So this would be for the JEP520. Okay, now
the slide for a while.
Yeah.
I think.
Yeah. So now to cryptography. Yay. Okay, the first one I think is kind of boring if I remember it correctly. Yeah. No, that's not true. Yeah, so this is the key derivation function API is just a new API for key derivation function. As I see it, it's just there's like they try to unify the way the how we generate keys and key material, like additional keys from the key material, which can be another key or some input noise or something else, so that you don't have to do it yourself, or so that there will be a unified way of doing that. Yeah, and why they have been doing this is the it should be one of the building steps towards hybrid public key encryption, which is a way they want to we want to improve our encryption to be quantum resistant. The idea is behind the hybrid public key encryption, or HPKE, is to encrypt, to have a symmetric key encrypted with an asymmetric quantum resistant key, and then sent to both of the nodes, so they can communicate with symmetric key without any disturbances, or how is it called when somebody listens to you?
Eavesdropping.
Eavesdropping, yeah, sorry, thank you. Yeah, so demo for it will be again a bit straightforward. So in this demo, I'm using the KDF to generate a key. We use the input key material, or IKM, to give it some noise. It can be also a shared secret or anything you want to. And yeah, you use this KDF API to generate a key that should be, in this case, it will be SHA 256, and I think it will be, I hope it will be the symmetric key for symmetric communication, but I'm not sure now. Yeah, I think I'll just show how it works, and then we can move on. So yeah, so this is the way of deriving new keys, like a new way of deriving keys from noise, and that's all this JEP is about, basically.
And if you run it multiple times with the same input, will it give the same result?
We can definitely try, and it definitely will.
So what the noise is doing?
You can, like the input noise in my case is static string.
I see.
So that's why the input is, yeah. And the optional salt that I'm adding to it is also the static string, which is not an ideal thing you want to do. And in ideal case, if the demo wouldn't be so dummy, it would be something more complex. Okay, on to the next demos. Yeah. So next we have the quantum resistant module-lattice-based key encapsulation mechanism, which is a long way to name your JEP. Yeah, so this is basically already a quantum, like we assume that it's quantum resistant algorithm that's being implemented here. We assume that's because, well, nobody has been able to come up with quantum algorithms that are able to decrypt, like not decrypt, break the lattice-based encryptions using the shortest vectors or the learning from errors. Well, we can talk about it later if you want. Anyway, the MLKAM is, as I see it, just another algorithm that you can invoke to get a key pair. So it is basically, like, for you as Java users or programmers, it's nothing that fancy. It's not going to make you somehow superior programmers. You will just use a new way of generating keys. We can see it in the code. So basically, I have two files, sender and receiver. Receiver wants to receive a key. So what does the receiver need to do is to provide a key first for quantum resistant key for communication, which is asymmetric, and it uses this with the good old key pair generator, and it uses MLKEM argument to get a quantum resistant key. And then it should wait. Where it should wait? Yeah, it should wait for me to run the other program, which is the sender, which will take the key that it generates. It adds another, like, it encapsulates a symmetric key with it, sends it back, or in my case, it saves it as a file. And then the receiver will encrypt it and find out whether what the key was. Hopefully. And we can also see the sender. Yeah, so what the sender does is that it takes the public key that the receiver provided, and using MLKEM, it adds where it is. Yeah, sorry, I have not seen this code for a while now. It encapsulates using the public key, yeah, well, we'll see what it does actually. Yeah, this should have not been a public key. This should have been the shared secret, I believe.
Sorry? Explaining it's good, just
thanks. So we can just Java see them both. And now I'll have to run the receiver. Yeah. So what the receiver did is, we can take a look in another terminal. it created this public key that the sender will use. We can take a look at a public key. This should be the, yeah.
Thank you.
It's not really readable. Yeah, so the sender will take this public key and the shared secret is this key that it generated, and it encapsulated it in the public key. So we can take a look how this encapsulation looks like. But since it's a bin file, I hope you don't expect anything readable. Exactly.
Not from cat.
I know.
We use hex editor, but Jiří is hardcore, so he just.
Yeah, I can read this, just no problem. Yeah, and now we can see that the shared secret is the same here as here. I could have encapsulated something better to look at, and not a key, which could have been a better demo, of course.
So the idea is that the shared secret is used for symmetric cryptography,
exactly.
which is faster probably than the
Exactly.
asymmetric
Yeah.
cryptography, and this is for like quantum safe lattice-based key exchange.
Yeah. So you will just use the quantum resistant keys for key exchange, and then you will like symmetrically communicate with symmetric keys.
And then you can use short-lived shared secrets.
Exactly.
Uh-huh.
Exactly. This is basically the idea behind the, how is it called? Hybrid public key encryption, which we strive towards. Yeah. And I have another demo. I don't know if I should touch you with it, but we can take a look. Yeah, so this one is really similar to the previous one. It basically is combining the advantages of the key derivation function and the quantum resistor Module-Lattice-Based, the JEP496 for short. And what this should do is that the receiver should again ask for a key using the quantum resistant key. That's the same so far. Here we have the key pair, public key, private key, and what will be different will be what sender does, or should be, if I remember the code correctly. And the sender should use the how is it called again? The new API for key derivation to get a symmetric key. Yeah, so this is the key derivation function, if I remember correctly, and it uses the new algorithm. Well, basically it's this just SHA256, but with the HKDF prefix. And so what it does is that it encapsulates the symmetric key for the receiver, which will be basically exactly the same demo. When I hear it now.
Thing?
Basically, yes.
So what's the difference?
Because in this case it uses the JEP510 to generate the symmetric key. I'm not sure. I was hyped and I wanted to do demos for everything. No. Bad completion. So what it did, it again generated public key. I don't have the hex editor, I believe. I don't. Well, I'm not going to look for it now. No. Yeah. and this time, okay. Oh yeah, yeah, I completely forgot about what this was doing. So what this does actually is that it not only generated the Java. Yeah, so the sender in this case, which I completely forgot that I put there, also generated the message there using the new AES key. So it basically encapsulated the AES key using the quantum resistant algorithm. Then it sent it to the receiver, and also used this AES key to encrypt a message that is here. So yeah, and we can say that it decrypted the message just fine. So that's it. Yeah, close. Another thing would be the lattice-based signature algorithm. The signature algorithms are much more complex, and I could explain to you the basis of the lattice-based algorithms for normal communication and asymmetric communication, but not for the signature. I'm losing that battle. Yeah. First show you the demos. So obviously one of them is going to sign it. This one is going to just create a message, and then it will output a message and its signature and a public key using the quantum resistant algorithm, or lattice-based in this case. So it will store 3 files, and the other one will make sure whether make sure whether it was sent by him or not, or signed by him in this case. Yeah, so it generated 3 files. We can get the message. This one will be readable. Hello quantum world. The other 2 will not. This is a public key that it will use to make sure whether the signature is correct or not. And the verify demo. These are not really simple demos, as I see them now. But it's really hard to make simple demos for quantum encryption, or any encryption at all.
It's good, actually, as I can see that it's just new key for key factory, signature factory, and that's all for us end users, right?
Yeah, exactly. Yeah. Yeah, it should not be that hard for programmers. Just the magic that's happening behind the curtain is.
Do you know if the algorithms are Java implemented in Java or in native?
I believe they are in native, but I can't really put my hand in the fire for that statement. Yeah, so signature is valid, and that's all I can show. I can show that if I modify the message, then the signature valid wouldn't be that the signature wouldn't be valid. But I hope that you believe me in that regard. And the last thing that I have for you is that we have a new unified interface for privacy enhanced mail, which is a format how we store keys. You usually know it if you even if you don't really realize it. This was the first time I heard about the PEM format as well for me. And the new thing is that it's also it's both unified, and it should by default use PKCS encryption for the key storage, which is not something that's like given by default. Usually it's up to the programmer how he stores his keys, so it should definitely improve the security. And the demo for it would be yeah, I don't know how I could have called these demos simple. Yeah. So here we just generate a key if the size of the 2048 bits. Then generate key pair, public, private. And then this is the new interface where we have a PEM encoder class that we can instantiate using the OF. I had an OnlyFans joke about this, but no.
Not on record.
Yeah. I got lost actually. Yeah, and then we just yeah, this is just to generate the string that's string representation of the individual keys, and we just write them down. That's all this demo is about, so you can see that. Oh no, yep, no password. Yeah. Oh yeah, and this one is still in preview. I know. I have burned myself there a lot of times today. No. Yeah, so this is the format in which we know that the I don't know how about you, but my keys are usually stored in this way in .ssh, and now it's unified in Java, and it should all be PKCS encrypted by default. And yeah, that's it for my part of the presentation.
One question to the Java flight recorder.
Yep.
You were avoiding using the dump on exit. That was intentional.
Dump on exit. Can you elaborate more?
Well, the JVM is streaming the Java flight recorder data, and if you terminate the VM, if it ends, some of them may be missing. And because you don't want to mess with the VM. But if there is a switch, dump on exit, which is ensuring that even the remaining data, which could be lost otherwise, will be printed to the JFR file.
Okay, I did not know about this. Thank you.
Okay.
Alright, so that's me, and now Karm.
Thanks, Eric.
What could possibly go wrong, right? I mean, it's just the speaker. We won't be needing that. Like, this is really not a stunt to capture your attention.
It works.
It was my desperate attempt to like cold reboot the laptop without battery to get rid of screen flickering and some weird artifacts on the LCD. It did not help, but hopefully the external projector would work. to change the.
It's good. It's good, just make it bigger. Or Magnus.
I'm trying to invoke the spirit of Magnus. No, it's kind of too big, right? I mean, this will have to do. Okay, so I'm Karm, and I'll be showing you enhancements related to Project Leyden, and that's all about doing work with your application ahead of time, ahead of the runtime. So when you start an app, there is a tremendous amount of work the JVM does. It wakes up, it starts to look for classes, it initializes itself. You could have some service provider interfaces. There are annotations. There is a lot of work that going to be scanned, looked into all your jars, class paths, looking for the whole dependency graph between classes and static initializers. There is a giant load of work before your application even starts, and then when it starts, it might also do a lot of initialization, a lot of work. I'll have some brief examples where it helps a little and where it helps a lot in its current stage. There is a even more extreme idea with closed world assumption. That means that you have all the data, all the bytecode, and all the configuration in one place at build time, and you could compile the whole application to a standalone executable. That's what Project GraalVM does. Project Leyden is focused on less extreme approach. It honors the open world assumption that Java has. It means that you can, at runtime, load classes, you can load additional jars, you can modify things at runtime. And the biggest win with Project Leyden is that you can use it to speed up legacy application without touching its source code, without trying to shuffle things around to make it ahead of time friendly. It would just work. There's been some work in the preview in past 3 JDKs. JDK25 brings some more updates, and it's going to be a long journey. It's still not done, not even remotely. What lands in JDK25 are 3 enhancements. They are related to the work done before the app actually starts, and storing that work in a binary file that's memory mapped. So after this trial run or training run, you can just use the memory mapped file and you don't have to do the work again. And then there is an attempt to look at what code is hot in your Java application, and that would eventually get JITted at runtime. And if it looks hot during the training run, we could JIT it now, and under the assumption that it would be hot again in your runtime. And we could store in this AOT file, we can store this JITted code and use it later at runtime. The caveat is that if your training run or test run is vastly different from your production, it won't help you anymore, but it won't crash. Like there is not going to be any penalty for having having more instruction cache misses because you are trying to push a lot of compiled code that's not needed because your hot path is completely elsewhere. There is no penalty if the runtime doesn't find the path hot anymore. It just won't use the JITed code, so it won't harm you. You just won't benefit as much. And then there is some syntactic sugar on the command line that makes it easier to use. And during the demos, I'll be using the enhanced, easier way to deal with it. So the keywords like AOT means ahead of time everywhere, and somewhere there is CDS dropped, like the acronym, and that's class data sharing, and that's like the previous or the groundwork laid in the previous enhancements that was necessary to even start with Project Leyden.
So JIT behaves exactly the same as it would with like normal Java run. So it can also de-optimize something that you originally planned to in mind.
Yes, but that has nothing to do with the AOT file anymore. It's just that if the runtime finds a path hot and that path has been already JITted in the AOT file, it won't trouble JITting it again and it would use it. I didn't say that, but naturally all this is platform dependent. Like you cannot create the AOT file and the test run on one system or with one JDK version or architecture and then run it everywhere. It has to be the same architecture and it has to be close to the production.
Well, did JVM detect that it's a different architecture, for example, and crash?
By default, nothing happens. It just won't use the file. But there is an option I forgot, and that it's like a flag you pass to the JVM, and that says that if the file is not useful, terminate. We can look it up later. So if something changes in your CI/CD pipeline and your training run and your production are divorced and it doesn't work anymore, there is an option that makes your Java runtime bail out at start and won't start at all. But it's not the default. By default, it will just ignore the file. So the original ergonomics was that you create a configuration with one run, and then you create the binary file with another run. JDK25 merges it into one command or one run, but you could still use the separate approach as well. The name of the file is arbitrary. I call it AOT, but you can name it whatever you want. So now it's simpler. With JDK25, you just have one training run or run where the application is actually started and its behavior is recorded into the file. We'll take a look at that file later. And then you have your production run that uses that file to speed up the start of the JDK itself and the application. So now a couple of demos. I've got Hello World. the idea is to print hello world to the terminal. So it should be really simple. The first implementation is just two syscalls in. Okay, now this is really too big, I guess. Yeah. The first implementation is in assembly. Why does it? Start name. Okay, so that's like the baseline I like to do to think about things. So when I run some giant Java web server, I compare it to HTTPD or Nginx to get some idea like how long should something take. We have the similar thing for C. That's much longer because it links the whole standard library, and the printf function is in itself big function. It gets gradually bigger all the way to Java. That's
can you show the assembly again? The results. The results of the scroll up. Side by side.
It takes like a half millisecond, and in C it takes almost a millisecond. The Java hello world there is no AOT. It builds a jar. I'm doing a jar here because the AOT command line ergonomics requires a module or a jar. So to be fair, I'm creating jar here too, even though it's not needed. And it takes 30 milliseconds to print hello world. I'm using like small command line utility hyperfine to measure the performance of some command line application. And I disabled turbo boost on the laptop, so the CPU behaves more consistently. But again, it's laptop. IntelliJ runs there. Like these performance numbers have no meaning on their own. It's just a rough comparison. And looking at perf, that's orders and orders of magnitude away from what it took to print the hello world in C. We have tens of millions of instructions just to print to terminal. To print the hello world with Java AOT, we take advantage of the new flags. I'll just make sure I'm on the right JDK. Yeah. I've been refreshing the web page with the build, and it's still not there. So we are using like early access version. The nice part is that the only thing you need to take advantage of the AOT and Project Leyden in JDK25 is to have a training run or a run where you build the cache, and then you have one more flag when you are actually running the application. And that's it. No modifications to the source code, no additional configurations, nothing like that. So we can build the AOT version. I'm including some logging, which is not necessary. You can see that we have only one class processed from like our application, because there is just a public static void main written in the old way. But there is already a lot of classes loaded and processed and cached from the JDK, because only printing hello world in Java means you are initializing class system. That's it. And there in the class system you touch threads, so you initialize a class thread, and there are sockets, and there are file descriptors and sockets in that class mentioned, and suddenly you are pulling initialization of the whole networking because of the sockets. So just to print hello world, we are initializing things related to IPv4 versus IPv6 in the Java runtime.
Can you try with IO? Can you try it with IO?
I'm not touching the example now. I won't repeat their mistakes, so I'm glad I have my lid on the laptop. And so we built that, and now we can run it, and we'll see that the benefit is quite small. It's there, but it's whoops, I wanted to change that. It's there, but it's small. We will have, this is the one using AOT, and this is the hello world without AOT. So we shaved off a little, but in the next example we will arrive at something where the benefit is much more marked. Next thing is web application written in Quarkus, and then we will take a look at example where we have a desktop app that analyzes images from microscope. So open world versus closed world. Quarkus can do the closed world assumption, so this framework allows you to build a web application in Java that's fully compilable into a native executable with Project GraalVM. Speaking of which, I'll take one more jab at this hello world. What if we compiled it with the closed world assumption completely to native? What would it look like? So compiled that way, the tool complains that the execution always took less than 5 milliseconds, so it's not reliable measurements. It's way closer to the C than to Java. No, this is hello world printed as a native image compiled with GraalVM. So it's Java native, and the build uses native image tool. So this is not Project Leyden. I'm just showing it here because it relates to the ahead of time compilation topic. This is the extreme end where not any Java application could be made this way. and you have to have everything in one place, all the bytecode, and there are limitations to what you can do in that Java code. Quarkus application. I stitched together an app that generates sunsets, and we will do a training run. We will do a training run. Yeah. So the app started, and we will access its endpoint. And my assumption was that calling Java 2D in the servlet a lot of times would make this path hot, and it did, but the difference between creating a good training run and bad training run in this scenario is quite negligible. But there is a huge difference between no training run at all. We can create a bad training run where we don't access the endpoint at all and just end the application. And when starting the web application, I'm interested in how long did it take to start. That's cool and looks good on slides, but I'm interested in how long it took to serve a first HTTP request with HTTP 200 correctly. I stitched together a little script that plays with it. It's scripted in Java. And it first uses the bad cache, and then the good cache, and then no AOT cache at all. It takes a little bit of time because there are some warm-up runs to populate the caches. So I hope it's legible, but I'll highlight the important sections. So we are looking here at two runs that use the Project Leyden, the JDK25 feature, without any more modifications to the source code. It's the same app, it's the same jar, in both runs. And with the bad training run, it started in almost 400 milliseconds. That's pretty much the same with both of them, but the good AOT run, the one we trained with the sunsets, was slightly faster to provide a first valid response. Again, compared to the application being compiled with the closed world assumption, that's pretty slow. But if we don't use any AOT cache, if we don't use this Project Leyden, if we don't use this new feature, we are looking at almost a second before the sunset, the first sunset was correctly served. So I just earned a lot of time without any work. The only work was that I added these flags to the JDK and I had one training run. Nothing more. And the training run could be quite stupid. Like you can see that even the bad training run, when we just started the Quarkus and shut it down, already brought us a huge benefit. So this is a huge win for free. Compiled to the native image. Again, this is not the Leyden thing. This is not the JDK25 thing. It gets us an order of magnitude better. It serves the first sunset, the first correct response from the web server in 36 milliseconds. That sounds incredible, but there is also a downside to it. I will show it. I will start the first native app, the one that was compiled with the closed world assumption. So it's just an executable. No Java is used. It started incredibly fast, and I will use this little app to hit it with some requests. And we can see that on average it took 16 milliseconds to serve the sunset. If I run it as a Java application, we can use the good AOT. So this is now, it started way slower, okay. As you can see that if the goal is to have a stable, really performant runtime, the good Java application that started slowly or compared to the native is faster at runtime, because there is a trade-off, and the trade-off is that the ahead of time with closed world assumption compiled app does no runtime optimizations. It does not detect any hot passes, it does not do opts and deopts. It's just fixed ahead of time as it was, without much clue as to which pass would be hot in the end. So the point to take away is that you can use JDK25 and Project Leyden enhancements with just one flag, and you can get a huge win at startup. Moving forward and gradually towards the end, don't worry. There are applications written in Java that are by definition open world, and that won't ever be able to be compiled with the closed world assumption. One of the example is Fiji. It's a life sciences studio that people use to analyze images from fluorescent microscopes and some pathology scans. I got it installed, it's written in Java, and I copied a plugin in it, a jar, that enables it to open CZI files, which are files produced by Carl Zeiss fluorescent microscopes. And this is how people use it. They distribute jars, they send jars to one another, so you can never have like all classes under ClassPass. It takes some time for it to start, and then you can browse the slices of the image. It's a desktop app. It's important how quickly it starts, and you can also script it with some macros. So that's another mayhem that would be uncompilable with closed world assumption, because you would never know what classes the user would actually touch in this weird macro language. What I will do here is that I will run the app with this macro to do something with the images, and measure how long it takes. So now, without any ahead of time compilation of anything, just plain JDK25. It starts the app, it runs the macro, it does a couple of operations on the image file, and then it terminates. And soon, hopefully, we will learn how long does it take. It was around 3 seconds last time I measured it. So it takes on average 3 seconds to do the operation, to start the whole application that loads a bunch of plugins and do something with the images. Now let's do a training run. So I have no power to do any changes with this code base. I'm not touching the source code. It's a giant mess. And it took a lot of time even to write this shell script, because it uses a native launcher. It's a mayhem. It's a legacy application that will never be compiled with GraalVM. But we will do the training run. So we will start it, let it do its thing, and terminate. And we got the AOT file that got 54 megs, and now we will use the file. So we will use the file to speed up the application, to speed up the process we've been doing. I'll again use Hyperfind to measure that. I hope no one has epilepsy.
After the sunset,
The guys already told me like that the sunset itself wasn't safe for work. So without it won't climb much further. So without doing any work with a giant legacy code base, like it uses mostly AWT. There are some plugins that pull Swing, and there are even some plugins that use JavaFX, and there is a lot of code written by scientists that do horrible Java. Like no one could ever untangle this mess of legacy plugins talking to each other. Without doing any work, I shaved 1 second, like 1/3, because it was 3 seconds on average. I shaved 1 second from this process. Open the Carl Zeiss file, process it, do the sciencey thing I need to do, and close it. So this is a huge win for free. And one last thing is our beloved Wildfly application server. That's tailored to more traditional applications that might not crave to be completely rewritten and compiled with closed world assumption. I don't have any web app written here, but what I've got is just a simple look at how long it takes to start, even on this crazy fast machine. I mean, I know it's falling apart, but it's solid inside. It takes, I'm lost in the, yeah, it takes, if I do it 10 times, do this similar, like it takes on average 2 seconds to even start, like the application server. And I can do this training run. So I'm just starting it and switching it off. And there is a lot of work done, not only for the JDK, but also for the Wildfly application server. I showed you with the Hello World example that there was only one class mentioned for the app, the public static void main and the main class. Here we have 1700 classes touched and loaded, and there is also a load of classes that was discarded by the current state of Project Leyden as unsafe to initialize ahead of time. And now when I start it, and I will just use the cache file, and I let the logging on, it shaved almost a whole second from the startup for free. I might get rid of the logging and it might get even faster. So again, a huge win, just right off the bat, something over 2 seconds, now it's something over 1 second. Like, I don't even need to do some charts to prove 1 or 2% improvement in long run. It's just that obvious win. One last bit, what is the file? I loaded the AOT file from the Hello World example here. The AOT file from Hello World has 10 megs. The AOT file from the application that analyzes microscopy images was 54 megs, and wildfly's AOT file is 80 megs. So there was a lot of things that Project Leyden at its current stage was able to cache in here. So this is a downside, that you would have to distribute this file along with your jars to get the speed benefit. It's a memory mapped binary file that begins with a magic number that identifies it, and then it has sections including like human readable version of the Java that was used, and that's also encoded there. So if you try to use the AOT file with a different JDK version, it won't work, it will be discarded. The format of this file is completely dependent on the particular JDK version you have, and there is no promise of any compatibility whatsoever. So you always need to do the training run and your production run with exactly same JDK version you created this file with. And one important section is that there is baked heap data. At the end, there is not much of it in this file because that was just the hello world. But there is a baked state of heap and a state of already initialized classes that would be just memory mapped and read and not initialized again. And that's it. That's the end.
One thing that I don't understand, when you have like web application like press server, like how long you should run that profiling, like the first phase? Like how should I know that I'm done? Should I just like run it and stop it like before like every deployment?
That's currently still being debated. Like Alexei Shipiev has two open pull requests on the OpenJDK project Leyden that are looking into C1 and C2 compilers. And there is currently no log message or no user-friendly way to know that you are done. Like you could start logging the tiered compilation, and you could start examining the logs and see whether your methods are already in the tier that they are compiled. So that you can do. That's something that's been in the JDK, I don't know, forever. This kind of logging. So you could do that in your training run to know, but there is no user-friendly way of doing that right now. Like there is no message that would say, okay, good, I'm not getting any new hot passes. I think you can switch it off. So what I did here was just ask for 60 sunsets a second for some time. Okay.
Yeah, I have still 4 more demos for 4 technical previews. Still there is a mood to look into that. Who is not interested may go home. If anybody will stay still there, he will see, she will see 4 demos for technical previews.
Guys, this is the longest jug that we ever had.
Sorry for that.
Sorry that I promised after party there will be no after party.
This is after party, the 4 tech previews.
Ne! Já jsem místo kabelu vytáhl ten zdroj a protože mám tu baterku odpojenou, tak to celé chcíplo teď.
Okay, get back.
Yeah, good. I'm iterating through the class file, which I read from the file. This is iterating through the file. If I am finding the method or field, I would print it out, nothing new. And this is how you transform the file. Again, I have read it. I have read it as a byte array, and then I will return it as a byte array, the new transformed class. Here I am iterating through the class model, and if I start a method, if I found a method which writes have this name, it would be omitted from the resulting bytecode. I'm repeating that this is designed to transform classes in the agents. So for example, the rename of the class is quite complicated thing. So yeah, that was for answer to question how the class file manipulation API looks. And the 4 previews are these primitive patterns in instance of which I will leave it to the end. But stable values. Stable values are a huge improvement to the JDK, to the Java language. They are promising to have the same performance for your lazy initialized complex singletons as the public static final something. The JET is promising the startup, but I have moreover failed to recognize that differences. I will tell you moreover why. Where I am. This is the class file API. Stable values. I am in this demo. I am generating a huge main class with a lot of singletons, which looks like this. So there is the private, not static, lazy initialization singleton. I guess everybody is using that. And there is the same public final. And there is a public final stable value, yeah, the new thing for the stable value APIs. And then the same with the static, that's all. So the static lazy holder, public static final, classical constant, and the public static final stable value. Now, if the huge main file is generally just generating several thousand of these slaves into one main method, and is measuring how quickly the application will start in several iterations to get the results. So this is final variable, so the final lazy initiated, moreover the same, so the singleton is really doing good job. And the stable value is, well, not that good. Surprisingly, it's delayed. Now we are in the static content, so the numbers are moreover the same. Static final lazy, obviously not enchanted anything. And again, final values, okay, it's delayed. Now there is a second approach where I am calling the instance and even telling the getter. So you see it got delayed, but again the stable values finalized, it's the singleton, as we know that, they are the worst. Again, I was playing with this quite a long time and asking the devs of that JEP why I am seeing that. They told me that I am seeing correctly, that final stable values are really adding logic on top of that everything, and you can expect delay in something that's straightforward. And the speed up should be in the complex applications, but the main benefit of the JEP is code readability. Now you do not need to think if it's public static final, if it's lazy initialized singleton, or if it's something else. You can just always use the stable values and you are done with that. So that's the lesson learned here.
So there is an expectation that if you are having a lot of stable values, that you should see performance benefit?
No.
No.
It really is, it's slowest of all the approaches. It remains slowest of all the approaches.
So
readability is great, and they said I was not able to replicate. They said that in a complex application where everything is bounded through, you should see even the improvement. I was not able to prove that, but let's trust them. And from code readability, I would probably recommend that. Now, Vector API is the probably longest developed change in the JDK. It's 10 JDKs in a row. It's already being incubated. Vector is a native thing for most architectures. Single instruction, multiple data. In the in the JDK, this is really super simple. There is interface vector. Do not mess it with the ancient Java util vector. There's nothing in common, and it is really dealing only with the primitives. So that's 508. Oh dear God. Yep. I will first launch that because the first one is pretty long, and it needs incubators. So there we have the running, and I will show the code. Yep. So what I'm doing there, you see that I have the arrays of the objects, array of the primitives, lists of the objects, and the ancient vectors. And with that, I am doing only one thing. I am only doing this. This is what operation which I am doing with all these arrays and so on, and I am wrapping some of the native arrays into the vectors. And what we will see, it's still running. Yeah? So the list, 386 milliseconds, I think that's the list is, sorry, that's how big it is. 100,000 members, no, not much, some iterations and some warm-ups to make it jitted and to have some averages. So 100,000 members only, that's a very small array at the end, as you will see. And this is what we see. List 386 milliseconds to just go through two lists and add the two values together. A list with the iterators slightly slower, and autoboxed array quite fast, and the primitive array that's super fast. For this reason, all other examples will be only with the primitive arrays, but I wanted to highlight how much faster they actually are. Here are some little bit more examples with that, like I am iterating one array and adding just two values of that one array or similar things. I will speak about it slightly more in the next demo. And I have also showed that there are the ancient vector, and these are the single instruction, single data. So you see that the operations on the vector API is just slightly faster. One would expect probably much more faster speed up than here. You will get back to that. And these are the ancient vectors which were later supplied by the Leyden. Just don't use them. They are anti-performance, anti-everything, and will be dead, I hope, soon. What we have in the second line. I have now dropped everything non-primitive and non-array because it's just slow, and I'm again just adding 2 values here. What we will see, it's much faster, but again the primitive arrays as we used before are moreover the same as the vector operations. In this moment I started to be slightly concerned and started to dig quite deep. One more example, just here I am instead plus 2 values plus plus, there is a little bit more multiplying, plus, multiplying, and again multiplying by -1. Yeah? Oh, and I forgot how to write it actually in the vector language. This is it. You create a float vector from the float array. Yeah, this is the array, and here is what type is to be seen there. Then you set what operation will be happening. So multiplying, added in negation, set it to the array, and that's all. The operation here, it happened and exported itself back to the array. So this is how you work with the vector API in Java. In that slightly small example, where it's just added the 2, you see that again, creating the vector, the operation here is just added and returning the array. This small hunk is here. If you have 2 arrays of different lengths, then the rest, which is on top of the first array or the shorter array, need to be processed in the old way. Yeah, I have the same array length, so I'm dropping that. So what we will see in the last example, in the heavy computation, it's not that heavy, but it's still something. Again, we are not joining. It's even slower in some cases than the arrays. Now, why is that? 2 answers are answering that. Anybody? There are 2 issues which I made. Anybody is willing to try to answer what went wrong? First, it's obvious, really obvious. The array is just too short. Yeah? You need huge arrays of primitive to really use that. And the second was slightly surprising. JIT is just doing a really good job. That's all. All this had warmed up and was jitting heavily. If I will, let's try the bigger computation that is visible a lot. Let's make the array longer, and let's keep some iteration, but remove the warm up. So the JIT will not be in the play. Hopefully that should do the job. Should, yep. So these 2 operations are on the half already. Yeah. So the vector API is giving this promise. This is still not that good, surprisingly. What to do is that? I had even longer run. Actually, if I would be adding more there, then we will never see the end. So this is the same. No, this is one more order. That's a huge speed up already. So that's it. I cannot JIT that. That would take long. We'll try. I think that 16 was the minimum for JIT 2. Let's try that. Maybe we will see the end. But then, maybe. We are seeing that. Good. It was JITted, not that much. Still much better. So these are the 2 things. More JIT, they are losing. More longer the array, they are getting exponentially. So that's for the vector API. Again, just look into that, how to create that, and there is a question.
But that's like, by JIT, you mean like it's the same array?
Yes. No. It's different array.
Just the operation.
It's different array and even different functions. I mean, I was trying to separate it as much as possible. I was not reusing JIT nowhere. Everything was fresh array, fresh function for everything. Yeah? And this is how you create it. And there is, for each primitive, there is that class which will help you. So no objects, just arrays, just primitives. So that was the vector API. And structured concurrency. Again, pretty long developed feature, 5th preview. And let's see the code. 25. There is quite a few demos too. But I will not launch all of them. So what we see that. Oh, I need to make it maybe slightly smaller. Still okay?
Yeah.
Okay. Now, what is there? There is application which is creating 3 threads and starting them. 1 thread, 2nd thread, and 3rd thread. They start, they run. We may end for them to finish. I guess everybody understands that code. Good. Going on. This is the same, only written with the lambda. Everybody understands that. Good. Now going to the really structured scope. The structured scope is auto-closable, so you can declare that like this. In this structured scope, we will be forking. This is already starting the new thread. It's the same content as we had before, so something which is iterating and is printing that is finished. There is the second structured scope, and then there I have smuggled the thread inside here, yeah? And there is a scope join. After you see this is the bracket, that bracket is probably the highest improvement here. We see where our connected threads are running. And then we can wait for them. One node here, in the moment you join, there's a scope join. Scope join means that it is waiting for all the threads in that scope to finish. So if I would scope join here, this would throw an exception that I cannot fork after calling the scope join. So this is still quite just example of how it works. Now we will be getting to the interesting parts. Threads, nice threads, scope, no more forks after join, but it's quite obvious. Now, there are some changes against the threads, which we will see. Now this is again the first example. Only the first thread is dying in some moment. Just a control question. If there are 3 threads running, one of them throw exception, will the other 2 continue running? Somebody thinks that no? Oh, they will. If one of them throw exception, the other 3 threads will continue to run. That's quite okay. I will show that. And then, just to be sure. So that's the exception in thread. Here we go. Nothing surprising. T1 lives, T1 dies, and T2 continue to live. Yeah, no surprise. However, in the thread scope, this is no longer true. Here I have structured scope again, where I am starting the same subthread, which is dying in some moment. Then there is a second virtual thread in the structured scope, which should be continuing, and then there is a old thread started in the same scope. This is slightly tricky, but just to show that it can coexist and may even have a meaning to exist. If we will be running this as the mine 5, you see that the exception killed the second thread. That's the huge difference. The exception from the first thread in the structured scope would kill every other structured scope in the same auto-closable block. However, we have seen that the thread keeps continuing. Yeah, so let's stay ahead. Yeah, T3 still lives. Important to bear that in mind. And the second thing is that you have the scoped values there out of the box. And this looks terribly. But if you compare it to what you would do with the thread and the scoped value and another thread, that would look much worse. And from maintainability scope, this is, it's quite better. So what's happening there? We have again the structured task scope ending here, and then we have the fork of that, as we have seen in previous demo, and in that there is the scoped value context, and in that context we are already getting the context. Unlike what we have seen in the original example 3 hours ago, I do not need to pass the context down manually, if I remember correctly. So when I'm starting another scope here, it's already inheriting the scoped value. Understandable? Good. These are the 2 main benefits of the 3 benefits of the structured task scope. that you can control them together, they will die together, live together, that they are inheriting the scoped values, and that they are much more readable at the end, really. So this was the scope values. And is there still some breath in you? Seems like yes, nobody is dying. So I will return to the primitive types in patterns because what?
I don't know, I just laughed, I'm sorry.
Something to think about.
That happens after 3 hours
of the Java. The most interesting thing, because here is what the Java C and Java VM is doing with that. So I will go to the code. 500 primitives. Yup. Boom. What's there? There is a lot of demo. This is case, how we know that. This is instance with the if, and now you can use instance of in the switch. Yeah? Now there is also guarded pattern, so instead of case and if something, you can do the guarded pattern. Yeah? So in the case you have this when keyword, and you have the primitive number in the pattern matching. Yeah? Let's moreover quickly this, but in this case, if I compile this, it would not run in JDK25 in no way. But let's see that actually, I probably need that source code. Yup, and we need. We will need to, yeah, that's just this, good. Then let's compile that, good, class is there, and Java runtime compiler from file system. What we will see that there, this is our class, Java assembly, we would see that correctly, I will again cheat it. You see that undev here, actually that would cause a bug in the older JDK. So this is disassembled, let's put it back, good. Now what the disassemblers will tell about that, because this is really quite interesting. The primitive pattern patching, we are doomed. Yeah, that's the reason why that would not run in JDK21, no way. The primitive pattern is just in hotspot and we are done with that. However, the others, the others in the switch are cheating us. And that cheating is like that you see that that is the source code. No, not that one. That's the guarded pattern. Where is that? Get double value guarded pattern. Let's try that. Yeah, here it is nicely visible. No, it's not that visible. So these two are both actually nice to see what the compiler and the JDK is using. You see that in the switch, it actually is calling method, which is returning just integer. This is slightly fascinating how to actually do all the tricks. There is a method, slightly artificial one, which is taking the instance of or whatever you want to put to the switch and is changing that to the integer. Done. Just an interesting jewel at the end. I was surprised to see that. I consider this nice design. And now you know that JVM is cheating you from time to time. So that's finally all by me. From the small conclusion at the end, I think that Java is going pretty well. That it's removing the backward burden of the applet APIs and the security managers, and that it is improving performance. And all that incubation time is giving developers to really adapt in time for the GA, and if the feature is complete, then it's getting feedback and improving as users need that. So yeah, that's it. That's all from us. That's covering jump from LTS 21 to 25 completely. Thanks you for surviving. 5 people. So that's that.
Amazing.
Thank you.
Okay, I don't think that I need to conclude. Amazing job, guys. Well, thank you all that well, were able to finish 3.5-hour deep
Thanks
dive.
to audience, able to finish.
I definitely believe that I have enough Java for today. But it was very interesting. Thank you guys.
Mám něčí prodlužku, teda adaptér.
No tak